Back to Wanna Watch Me Code. Um, Today is a special day. It's an anagram day, so that's pretty cool. It's gonna happen for the next few years, I think. But yeah, today is 4/20/2024. And if you read that backwards, it's 4/20/2024. It's the same either way. It's pretty cool. Anyway, what are we gonna do today? We are gonna see where we got last time. I think last time we created the network table. Let's see. Yeah. Okay. But today actually we will do some timing. Whoops. What I want to do basically episode is to for the health check calls, do timing on how long the request took, and store that information in the lookup table. That way we can get an idea of the latency between two of our two hosts or computers on the network. And then we could do some pretty cool stuff with that. We could determine if there's I don't know, on the decentralized network, if we wanted to exchange data, for example, and there's multiple different servers on the network that have that same data, they could prioritize getting it from whatever server is giving it the fastest response. Another use case would be potentially, which I want to actually do, is routing of network traffic. So exchanging with other nodes on the network or hosts, their network tables with their latencies between all of their connections, and then route traffic through all of those hosts with the minimal path, and doing like a graph search to find that once we get all that information. And this is Twitch, so I guess a lot of the streams are about gaming, so I had some ideas on that. So like if each player of the game was, I mean, they're going to be different pings, right, and different latencies between them and the game server. So with this timing, we could potentially adjust for the latency between the end client and like the game server. So, and like maybe be like, all right, like they were going this direction, but it took like a second to get to us, so like they're actually this far ahead or whatever. But anyway, let's get going. So what are we gonna do? This could be definitely cleaned up. I forget. Okay, utils, network. So we created like and this is during the silent session, so maybe I could just recap what we did. So for the network, I just kind of created the pattern here, or object-oriented structure for holding records in the network table. So this right here, this is just like the status of a host, and I use like kind of the gaming terminology where you basically have like a number of this will be like retry attempts, right? So if it goes beyond it, if it tries beyond this amount, which every failure I'll decrement this by like 1, and then when it hits 0, we would then not try and connect to it anymore, and maybe we would evict that record from the network table. or just set a flag that just says it's inactive, or just allow us to infer from this that they they're dead or whatever. So and then when they can just reconnect in that case and get more lives. Health check configuration. So this is okay, so this is gonna be like the port for the health check, and then you might be thinking like, why would you why would I create a separate configuration just to hold one value? Why not just put it in here? And the idea is that there's going to be more configuration, and by putting it here, it like will declutter the higher level struct interface, I guess. Yeah, because like it's good to think about those things up front, because like once you get to like the health check having flat like 100 records, it would be easier to just be like, all right, I don't want status details, I want like a configuration, and go there, and then you can see what's there, and it's like a subset. So just for I don't know where I'm going with that. It's just I don't know, it might be overkill for now, but I see the health check configuration set getting larger. Okay, so then we have network details, which is just the address, and then the health check, to keep them separated. Network details storage. So this is our actual structure, like for holding our actual network table. So the network table is actually the host map. Just initialize it there, and we put it in mutex. That's for when we have concurrent access to it. It'll right here lock that mutex, or wait for that lock, and then operate on it. And when it leaves this scope, it will release that lock, and then whoever else calls get network details can acquire that lock and do the same operation. And then put network, so like add and put, it's just like it's basically just a map, or table, or like whatever you want to call it. It could be a database, but I wanted to do everything in memory on host for now, for speed. But it would maybe be nice to have a database that, like, because I don't know that I want to put, well, I know I probably don't want to put everything in this package, so I don't know. I'm just trying to think of, like, because one thing I want to do is potentially for the exchange of table information, I would probably do that with just a typical HTTP web server, because and TCP, so that I don't have to worry about all of the organization of all that stuff. And it's a lot quicker and easier. A lot of stuff gets done for you. But the health check is kind of, I want to do this at least. Oh, the one thing last time, I think adding logging reduced, or like impacted performance a little bit, just because we are, we're getting like the measurements I was getting was like 20 microseconds or something. So like really any extra line of, like, at that like performance level, like I feel like any extra line you add is gonna affect it. But maybe there's I don't know, a better higher performance like logging library. Like, I don't know what these logs are like fully doing under the surface. Maybe I can like defer the logging, or like send it to a pipe and then unblock like this. But even that, like, I don't know, it's like this just isn't doing that much. So anything more we add is like doubling the amount of operations it's doing. But I mean, not really, but it's probably doing a lot, getting the mutex under the hood. But Okay. Yeah. So and then okay, these are tests. So we have tests. Haven't looked at this in since last weekend. Uh, Health checker. Okay, so it's just the old stuff, right? Yeah, these aren't used, I think, or are they? What do they take? Yeah, I don't think these are used. I need to figure out how to do this, or how the results work. That's also one thing I was thinking about was the fact that another thing, I think I added context or something here because I realized I didn't know how to get the network detail store into the. Oh yeah, actually it's good. Uh, so yeah, I actually implemented the ACK opcode handler in the for the health check that the health check broker ultimately invokes through like a consumer of the other end of the pipe that it writes this output to. So let's see, up here is where we invoke it. And the one thing is I put it into a map, and what I wanted to do is make like a const map. Oh, you know what? This is fine, dude. Sick. Okay, yeah, I did. That's fine. Yeah, I wanted it to be constant because I didn't want to initialize it every time. But so I was worried that I was literally calling this here when I'm trying to use it and basically reinitializing a new map, wasting memory and time. But it looks like just when I construct it, it initializes once. So that's good. Okay, cool. Got this comment out method. I don't know. I guess. I don't know. Let's go. Opcode handler, message sender. Params is params. Wait, I could have. Yeah. So I don't know. I get another thing. I could have definitely. I mean, I could have put the context within the opcode handler params. But I thought that like they kind of serve different purposes, and I don't know, but yeah, okay, I think I get existing. Okay, and then yeah, I check if there's a record for the response from the health check for that end host that I just health checked. So then we'll update it. And right now the strategy is to refill all of their health if we get one successful health check. So like say they have 8 lives, they get down to 1, and then the last one they respond to, we'll refill it all the way. But I want to make this more of a have a strategy pattern that I can just modify how we handle that. But for now, that's fine. And then we decrement the amount of lives remaining if oh no, we don't. Oh, actually, so okay, so it's like if they're not, I use basically if they're not connected already, and then if they are connected. So actually, I did do it. I each time I get a healthy check, I increment it +1 until it hits the max. Max allowed, because if it just incremented indefinitely, like this, if they're connected for a really long time, then they could have 1,000,000 lives, and then the health check is basically worthless. Okay, health check contacts, and that's how we get the data store in there. And then, okay, so I have no test for this. This would be, I feel like, would it be hard to test? I guess not. I could just yeah, it's not too bad. Okay. So, let's see, what are we gonna do? So, it's interesting because everything's like so asynchronous here. So, what I want to do is measure, like, when I make a request, I want to start the timing, and then when I get the response, I want to stop it. Um, and that will, I mean, not necessarily even stop it, just could be like like timestamps, not timestamps, but like nanoseconds from epoch or something. And then or my, I don't know, like a very fine tuned like a lot of I don't know, a lot of very small amount of time measurement, right? And then I want to I'll probably take that and include it in the to the handlers, and then they'll write it to the network table. But like I was thinking, like, I could, when I make the request, I in the broker I could get the current like epoch time, and put it into like a table, and then with the nonce, and then when I get back a ACK response with that nonce, um, take another time like epoch timestamp or like now time, and then calculate, and then pass that down through the output stream to the handlers. Cool. So let's take a look. Health check network broker. Okay. What's this, dude? This was when I was, I don't know why that's, I think I just made I just made a function for it. Yeah, I made a struct that was going to be a factory class, but I was like, this isn't Java, I can just make a function for this. I was just so accustomed to wrapping everything in classes, but it's like, this is fine. Okay. So we got check sender. Okay. So it's fine. Network broker message. I'll check network broker message. Okay. Right. So, okay. This will be interesting because sender. Is this the? No, this isn't even it. Is it? Okay. Here we go. Find debug. Health check network broker. Socket bind. Socket bound. I feel like I shouldn't have any logging in this layer to make it as fast as possible. But then I'll have no idea what's going on when I need to. Okay, response sender, the socket. Okay, no, I am just using the functions. Okay, health check receiver. Can I add like maybe, yeah, I wonder if I can. So I'm thinking is if there's like a annotation or something that can do some of this for me. Could use metrics, but let's see if there's any, like, what kind of open source metrics type stuff there is. No way, is this built into Rust? Histograms. Yeah, shit, dude, I should counter anchoring, absolutely. Describe counter gauge histograms in order to determine recording trait defines the interface with registration emissions macros and exporters just how to refer concrete implementations or refer the trait defines with that. Okay, is it where I can give a key? Query, wrong query, delta start data labs. Histogram record delta. Process dot query row count. That's weird. So, problem is I'm gonna have to like, okay, so I could do it similar. Okay, so I could store the oh wait, it's just instant. Wait, it's just a function. Hold on. Wait, process. Oh, okay, let me just read. I look at the code too quickly, right? Metrics crate to emit libraries need only include the metrics crate to emit metrics. When an executable installs a recorder, all included crates which emitting metrics will now emit their metrics to that record, which allows library authors to seamlessly emit their own metrics without knowing or caring which exporter implementation is chosen, or even if one is installed. In case where no global recorder is installed, a no-op recorder lives in its place, which has an incredibly very low overhead, and an atomic load in comparison. Libraries can safely instrument their code without fear of ruining baseline performance. By default, a no-op recorder is present so that macros can work even if no exporter has been installed. This recorder is extremely low overhead, relaxed load, and conditional, and so practically speaking, the overhead when no exporter is installed is extremely low. You can safely instrument applications knowing that you won't pay a heavy performance cost even if you're not shipping metrics. Okay, this is the no-op. That was weird. It seemed like it repeated itself, but row count, yeah. Okay. Warning, the metric system may only be initialized once. Got it. Can I just log it? Do you want to just log the metrics? Okay, I'm doing. Okay, keys. All metrics are in essence the combination of a metric type and metric identifier, such as a histogram called a response latency. Registration. Recorders must handle the registration of a metric. Keys. All metrics are in essence the combination of metric type and metric identifier, such as histogram called response latency. You could conceivably have multiple metrics with the same name, so long as they are different types. As the types are enforced, limited by the recorder trait itself, the remaining piece is the identifier, which we handle by using key. Keys hold both the metric name and potentially labels related to the metric. The metric name and labels are always string values. Okay. Internally, metrics uses a clone to write smart pointer for these values to optimize cases where the values are static strings, which can provide significant performance benefits. These smart pointers can hold own string values, so users can mix and match static strings and own strings without issue. Two key objects can be checked for equality and considered to point to the same metric if they are equal. Okay. Equality checks both the name of the key and the labels of a key. Labels are not sorted prior to checking for equality, but insertion order is maintained. So any key constructed from the same set of labels in the same order should be equal. Insertion is maintained, okay. It is an implementation detail for a recorder wishes to do a deeper equality check that ignores the orders of labels, but practically speaking, metric omission and thus labels should be fixed in ordering in nearly all cases, and so it typically is not a problem. Recorders must handle the registration of a metric, and in practice, registration solves two potential problems: providing metadata for a metric and creating an entry for a metric, even though it has not been implemented yet. Callers may wish to provide a human-readable description. Okay, mission. Likewise, recorders must handle the mission of metrics as well. Comparatively speaking, mission is not too different from registration. You have the same key as well as value being emitted. For recorders which temporarily buffer or hold on to values before exporting, a typical approach might be installing recorders. Recorders, also referred to as exporters, must be installed such that the mission macros can access them. As user metrics, you'll typically see exporters provide method to install themselves that hide the nitty-gritty details. These methods will usually be aptly named, such as install. However, at a low level, this can happen in one of two ways: installing a recorder globally or locally. Global recorder used by default, that the macros used by default is stored in a static variable accessible by all portions of the compiled application, including dependencies. This is what allows us to provide the same initialized once benefit anywhere behavior that users are familiar with from other telemetry crates like tracing and log. Only one global recorder can be installed in a lifetime of the process. If a local recorder in many scenarios such as in unit test, you may wish to temporarily set a recorder. Got it with local. Okay. How do I use this? That's it. Okay, let's get it. Okay, so let's see. You know what? I think I'm gonna just use logs and forget about it. I don't think I need. Do I actually need this though? All it does is measure time anyway. Okay, let me just update the logging, and I'll just do that. I don't feel like doing these metrics. Feeling lazy right now. I already have it. Oh, right. I forgot. I added this, I think. Yeah, I already measured it. Totally forgot about that. Let me just run it. Let's, oh, no, but we want to, okay. Single instance main, Oh, yeah, that's the problem. Yeah, this doesn't actually measure the request response time. This is just how long it took me to write to the pipe or the channel from the main thread. Forgot. Yeah, it's the issue. By the way, all this code is on GitHub, right? Open sourced. Let's go sign in. Nope, wrong one. Oh no. Not sure. One sec. Alright, my bad. I don't know why it's, do I not use Chrome for this? Gee whiz. Let's go. GitHub. Come on. Be signed in. Yeah, sick, dude. Yeah, so it's under Swizzy Decent, so it's all here. I don't have a README yet, but yeah, that's what we got. But anyway, if you want to see what it does, just if you click a button, it will make a request. So it is it is making the health check sync request, and then getting back the acknowledgement and printing out. Oh, and actually, yeah, last time I updated it so that it put the record in the network table, and then here it's just logging the network table information. So it's just localhost. It's just a what's it called? Basically it's health checking itself. So network table. We got the health check port there. Lives remaining. And so yeah. Actually, you know what? We're gonna make this like, let's make it CLI for it, I guess. I wonder if there's any easy way to make a CLI in Rust besides me just doing it whatever way I feel like it. And build CLI app in Rust. Dude, I hate this command line apps. CLI. Okay, so what CLI? This is a library package command line app. Cool. It seems like whoa, nice. Whoa, sick, dude. Oh wait, am I already using this? Let's see. Where am I reading? Oh, I'm just reading from Rusty. Sick, dude. This is awesome, dude. If this is CLI input file to read, number of lines to read. Okay, and then just main auxiliary. Line print line args.num line print. What does this okay, this is just getting, okay, so CLI input file to read, struct opt, I guess it's optional, the num. Okay. Okay. Well, let me open up the CLI book. Project setup. New run. Okay, that's fine. Parsing command line arguments. Okay, so I got the loop already. I just do. Oh, dude, I just swapped this out, dude. Okay, let's see. Let's get back. Let's go back to the example real quick. Not that one. Let's go here. Okay, so let's just do. Yeah, screw it. Let's go here. I don't know why I just went black. I'm gonna do. Put it up here. CLI file. I don't know why. I don't think this needs to be. Oh wait. Is CLI like, or CLI just one CLI command, or? How do you know which CLI to use? Hold on. Just go back. Parsing command line things and getting. I don't know. Pattern path. I'm confused. This doesn't look what they showed. Oh, that's just their what they're trying to do. That's their... Okay, first implementation. Content lines. Wrapping up. I want to update my title. Cool. It's good. Good not read. I'm just like, this isn't this like. I'm just so confused. I'm so confused. Okay, communicating with humans. Okay, well, let's just get set up, dude. Kroger, New Jersey. Okay, is it just built in, I guess? New Jersey. Oh, what? Wait, I don't understand. No, that's just the old way of doing it, right? Yeah. Okay, let me just copy this. I already did. Basically. Okay. So we'll do first command. No wait. Health check file. Nope. IP address. Port. Yeah. Issue 16, right? Let's see. P. Okay. I don't know if that'll work. Let's give it a shot. IP listener for IP address. Okay, sender address. What is IP address? Okay. And then we're just down here, right? And then we generate nodes. Health check network breaker message. Where do we set the sender address? There we go. So we're doing a self health check here. Where did I put that other thing? Okay. So we're gonna do. No, what do? We do what? Go here. Let's see what our parts. Health check parts. I don't know why import parts. Wait, was that right? Yeah, okay. Okay, what was it? Parts? Right. Cool. Nice. And then we'll do Like, what did I do before up here, dude? IP address from string, but I had a string at the port. Oh yeah, that's what I want. I forgot, dude. Args. Oh wait, did I make it? No. Wait, where did I put that? Where is that? There it is. IP. Oh, I wonder if that works. Alright, we'll try it. Alright. Actually, no, dude. Just like this. Stop. Oh, socket address. Shit. Remote address. Oh, okay, right. Can I just do socket address? Args. I don't think it's gonna work, but we're gonna give it a shot. Once we go up here and do socket address. There we go. And this socket address. Okay. So that. Let's get down here. Args, right? Socket address. Okay, and stuff's not right. Maybe it's just common. No, there's a lot of stuff going on in here. Oh, I know why. Because I need to comment out that. I think that one. Okay. Alright, let's run it. Let's see. Okay. Wonder if anyone's watching. I need a new laptop though. I think I'm gonna get one in about a month. Anyone have any recommendations if anybody's watching? Maybe I can just ask it in the channel. Okay. Still compiling. I'll be right back in a second. We back, and it didn't work. Found a documentation comment that doesn't document anything. Are you serious? That's a. Let's go here. Alright, let's just. Oh, that's how you document with 3 slashes, dude? No. I don't know. Okay, it's that. Is that. redundant args, and I knew that was gonna be an issue. It's gonna be like, I don't know, what is it? I forgot what it is. So like, no. I don't know why they make it different, you know? I guess they want you to think about it more. Where are we going? Where is it? Network utils, example, health check. Example, hopefully, because I did some logging there, right? And this is all commented on now. Where's the console? There we go. That's what it is. I don't understand why that. Wait, is that what I had? I tried like every other combination, and I'm still doing it, dude. There we go. Is that really what it is? Yeah. Okay. Args. Okay. So let's see now. This takes forever to compile though, so if anybody wants to join in and let me know what kind of laptop I should get, that'd be great. Successfully. Did it run? Oh, right. Interesting. That's not nice. Wait. I'm confused. I didn't type anything. What? The following required arguments were not provided socket address. Because I don't have my. Right, but why does it say it's required? Because I do unwrap or. Okay, right. So I'm down. No, but socket. Oh, but this is from. Fine. It doesn't. Swizzy decent socket address. Oh, no way. Oh, it's like, this is this, oh, it wants it, oh. That's not what I want. It just reads it from, okay. Okay, that was not what I thought it was gonna be. Why is it, yeah, I'm an idiot, dude. That's what it said it did. It says it reads it from environment variables, but no, but okay, parse. Can I change how it parses? Can I pass? Yeah, I can pass a string, right? Parsing command line. Okay, it's parsing command line. Nicer error reporting. Signal handling, using config files, communicating with humans. Args.pattern. Okay, yes. Damn it. Alright, so I'm just, wow. It's disappointing. Let's get SDN back, let's get rid of this stupid thing. Let's go back here. Steel line. Let's see. Command parser prompt, yeah, maybe Rust. Rust speed, safety, and single binary output and cross-platform deal language. Okay, it makes it a great fit. No, this is not what... Dude, are you kidding me? I don't want you, AI. You failed me one too many times. Starship? Is it free? Is it open source? Rust powered. It's a rocket. I feel like, oh no, I know what rocket is, right? That's no. Okay, what is it? I want cross shell prompt, minimal blazing fastening from manually customizable prompt for any shell. Works on most common shells, on most common operating systems, use it everywhere. I don't know, let's go back. Command line apps, Rust programming language. Read 2 string args file lines, take for each. Alright, folks. I mean, whatever. Let's just actually write some code today. Jeez, man. Okay, SDN. But how do I can at least find a parser. Rust. Okay. Lexing and parsing Rust compiler development. Okay, I don't need that. Beginner guide to parsing in Rust at first. Unit plus JSON document and scanner characters characters.get self cursor peak is done pop get self cursor character refactor string as follows scanner pop string unit the take method scanner take and star so here's regex, dude. Let's just see regex Rust. I'm gonna get a regex editor. We're just gonna parse the string as regex, dude. To use regex in Rust, this is AI again, dude. Add regex crate. Okay, it's at least 1.0, that's good. Import the regex crate, create a regular expression pattern. Use regular expression pattern. What is a regex in Rust? Okay, let's just do that, dude. I'll just search type. I like this IDE, dude. It's how it picks up the dependencies pretty well. Okay, and then we'll just do like, now we can like actually print line, but we don't need the print line because it's already there. And then we'll do parse command line, and then we'll create parse command. Fun parse command and line will be a string, right? No, it can be in string, dude. Right, I think that should be where we want. Okay, we want to. Oh no, don't do that. Okay. I think it like added that, right? It keeps doing that, dude. Why is it doing that? It should know better. Or am I not? What's going on here? Why is